This project is a deepfake face detection system built using Python and deep learning. It detects whether a face in an image or video is real or AI-generated using a trained ResNet-50 model. And the motto behind this project is detecting deepfakes to protect truth and ensure digital authenticity. This project detects deepfakes using a ResNet-50 model trained to classify real and fake faces. A Flask Web App allows users to upload images, videos, or use a webcam. It performs frame-level analysis on videos using OpenCV, optimized with frame sampling. A threshold-based decision system is included to adjust classification sensitivity for better accuracy and control. This is an architecture diagram. An architecture begins with data gathering and pre-processing of media, followed by training a ResNet-50 deep learning model. A Flask-based web app handles media uploads, while OpenCV processes frames in real time to detect deepfakes. Results are displayed with confidence scores, and all detection history is logged for future reference. Now let's talk about the flow chart. The process begins with media is collected and pre-processed for training. Then, a deep learning model is developed and trained. The model is integrated into a Flask web framework. Next, image and video inputs are analyzed for deepfake detection. A performance dashboard displays key metrics. User experience is enhanced for better interaction. Finally, the system is tested and deployed for use. The software requirements are divided into 5 categories: HTML, CSS, Jinja 2, JavaScript, and optionally, Bootstrap for the front end. Backend is powered by Python, Flask, PyTorch, OpenCV, and NumPy. Data is stored using sessions, file systems, and JSON. ResNet-50 is the deep learning model used. Basic system requirements include OS, RAM, GPU, browser, and IDE. Let's begin. As the screen opens, we can see the user interface. This is the main dashboard of the application. From here, the user selects the function they want to run, and we can see the application responding in real time. Here, the user is inputting some data or setting configuration values. This step is crucial for the back-end logic to execute correctly. For instance, if it's a sensor-based project, this is where parameters like thresholds or timing intervals are defined. Now, the main process is triggered. This might involve running an algorithm, triggering a sensor response, processing data, or controlling hardware components depending on your project type. And finally, here are the results from our deepfake detection system. In one case, the system detected a deepfake, with over 81% of frames flagged as manipulated, clearly marking the video as fake. In contrast, the second video was classified as authentic, with only 8.8% of frames showing any signs of manipulation. That's well below the threshold, so the model confirms it's a real video. These examples demonstrate how our system accurately analyzes and classifies video content based on frame-level evidence. This brings us to the end of our project demonstration.